All right, so for tangents, we talked about circles in the past, and we've talked about the area of a circle, the circumference of a circle, all that great stuff. So we're still starting with a circle, so draw a circle, right? Properties of tangents, it has two specific properties. Property number one, what is a tangent? Anybody? Tangent is when you have a line that intersects a circle at one point. So to know that a tangent is a line that intersects a circle at one point. So tangent is a line that intersects a circle at one point. What do you call that at one point? What is the one point called? So I'm going to call it over here P. I'm going to call it P because that's the point where that line touches the circle. That point is called a point of tangency. So now we're still looking at tangent, but not the trigonometric tangent. Now it's just the line tangent. And then when you get to pre-cal, tangent will have a different meaning. Okay? So tangent today is where one line touches a circle. Tangent is when the line touches a circle at one point. Okay? Now, properties of a tangent. Tangent has two main properties. You ready? Property number one. I'm just going to draw it. There's the center of my circle. What do you call a line that goes to the outside of the circle? A radius. So property number one, a radius always meets a tangent at 90 degrees. So a radius is perpendicular to a tangent. No matter what tangent line you draw, there will be a radius that is perpendicular to it. That's why I have this picture right here. A radius and a tangent are perpendicular to each other. Cool, right? Is that confusing to anybody?
Are you there?
Are you there? Are you alive?
Are you there?
Mr. Baker's mathematics. Yes. Yes, I do. And you're in your office or in the hallway? Alright, I'll send her. Kyla, Overholzer's office. Anybody concerned about the angle measure made by a tangent and a radius?
Why don't you take my stuff?
I don't know, it wouldn't hurt. Okay, so that's property number one. What's this angle right here? Okay, thank you. We do have it. Now, property number two. If I have a point outside of a circle and I have another tangent line extending from that point, aka we'll draw a different color line. How about a blue one? From this point, tangent to that circle. Property number two states that the length of the tangents are congruent. So this piece from here to the point of tangency is congruent to this piece from here to the point of tangency. The length of the tangent lines is congruent from the common endpoint. And that's where I broke you. Does that make sense? So if two tangent lines share a common point, the length of those two tangent lines is congruent. Does that make sense? Yes, sir.
What if two tangents lines share the same point of tangency?
Then it would be the same line of tangent. It would be the same line. There is only one point of tangency. If two tangent lines share the same point of tangency, it's the same line. Right? Because there's no other way for me to draw a line that, because then as soon as I shift this line like this, now it's inside the circle. So the only way to draw a new line is to rotate that line around the circle. Okay? So I could draw another line. Let's say that these two, I'll draw a black line. I say that this is a common point. So if I draw a line tangent, we get what's known as an inscribed circle. Right? Now the circle is inscribed in the triangle. So that's going to kind of key you to see things like this piece and this piece are congruent. This piece and this piece are congruent. Common endpoint to the point of tangency. These two pieces are equal. These two pieces are equal. Those two pieces are equal. They'll ask you like a perimeter question. What is the perimeter of the triangle? All right, so is anybody smart enough to see where this is going?
We have to find
Triangles and circles inside of triangles.
What do we have here?
another
A right triangle. What do we do with right triangles? A lot of stuff, don't we? It's gonna be fun. You ready? I'm having a good time. That's pretty much all I need you guys to understand about tangent lines. Two main properties: a radius meets a tangent at 90 degrees, and two tangent lines that share a common endpoint are congruent. Okay, everything else we do will be a derivative of that. That's a tangent joke. Hopefully you get it later. Skip it. Skip it. Skip it. Already talked about all this. Boom, here we go. We have two tangent lines, and we have a length of two tangent lines. What is the mathematical relationship between those two lines? They are equal to each other. So, it is mathematically appropriate to say that 6x squared is equal to 12x. Now we're using geometry to do algebra. What is x? Yes, sir.
Wouldn't it be congruent, not equal?
Congruent and equal are the same thing. The lines are congruent, the values are equal. Okay? Does anybody know how to solve this? You guys are uber quiet today, which means you don't know what's going on.
You
What?
Divide by x.
Okay.
6x equals 12.
What is 6 divided by 6?
6.
1.
1, yeah.
X squared divided by x. 12 divided by 6. X divided by x.
0.
Huh? Okay? 6.
Let's check it.
What does both sides share?
That's
An x. So I can eliminate that. That is called the property of equality. Now you have 6x equals 12. How do you
Divide by 6.
divide both sides by 6? You still get x equals 2.
x could also equal 0.
Okay? No, it can't. What's 12 times 2?
24.
2 squared? 4 times 6? 24. If x equaled 0, it would not be a line. Doesn't work that way. So it has two answers. One answer is extraneous. Okay. Yeah. How about this one? Third period lost their
Oh,
marbles.
it's easy.
Okay, go ahead, Mac.
So it's basically like
Allow me to remove the distraction for you.
Didn't I just give you all the answer? Dude, that's what I was gonna do.
So, now what do you have?
You have a
Right triangle.
You have a right triangle. And then what do you do with right triangles? Write this one down, please. It needs to be in your notes somewhere. So I can just call it a 30, 60, 90.
Nope.
No, you can't make that up. It has to be written there. The only thing you can do is Pythagorean Theorem, because you have three sides of a triangle. You do a squared plus b squared equals c squared. Now I've removed the distraction. There was a circle there. So I'm going to put it back. Okay, it is really wise to know which one is A, which one is B, and which one has to be C.
The 6x is C.
Okay, so this is my C side, aka the hypotenuse, and then we can call this one A and this one B. It doesn't really matter. So we go back to Pythagorean Theorem, just like on your CA review. A squared plus B squared equals C squared. And what is the length of C?
X plus 6.
X and 6, aka X plus 6. Not 6x. Thank you for distinguishing that. All right, and then we just algebra, guys. Just algebra. X times x. X squared. 9 times 9. 81. X plus 6 times x plus 6.
Something.
Oh, wasn't it like X squared plus 12x plus 36?
Now, some of you guys are wondering, how do we get to that? So you can go over here and you can multiply out x plus 6 times x plus 6. And then combine like terms. And that's how you get here. Well, I remember I told you guys you can mental math this. Double it with 6 plus 6. Square it. So you double it and you square it. That's how you get 12x and 36. It's just a really quick way to cheat. Okay, so we got past multiplying x plus 6 times x plus 6. And here's where we're at.
So, move 36.
No.
You
Cancel out x squared.
Yes. Both sides have an x squared. And this will always happen. Bye, Felicia. So now you have 81 equals 12x plus 36.
Subtract 36.
Now we subtract 36 from both sides. Something, yeah.
Divide by 12.
Divide both sides by 12. Three point something. I'll write that on my test and hope I get credit for it.
Hold up, I got this.
Yeah, the machine will do it for you. It's been there all year.
3.75.
3.75. And then here's where the dagger comes in. The hardest question of the day. What is 3.75?
15
The radius. Did anybody make that connection?
Oh,
The radius. Now x is 3.75. Now, once I have a radius, what kind of fun stuff can I do with the radius? The circumference, arc length, area, finding a sector. The limits, the options are limitless. So you did all that math to find r, then I could make you do a bunch of other stuff. Are you kidding me? It's great, right?
Why are you doing this?
Because, so, the vocabulary word, which one is the tangent? How long is the tangent? How long
Tangent
is
line.
that tangent in that problem?
There is no tangent.
shame on you, son. Whole, we don't even know which one the tangent is, do we?
Wait, no,
it's
it's
the
the 90-degree angle.
It is. This line is a tangent line. You can, oh baby Jesus, all you want. Why is that line a tangent line?
Because it's perpendicular.
Because it forms a 90-degree angle with the radius. Now, when we get to 3 days later from now, and I say the secant is equal to the tangent squared times the first part of the secant times the whole secant. What? You have to know these vocabulary words. What is a tangent? What is a radius? And we'll get to secants later. Tomorrow's chords. 3 words I'm introducing to you guys. Secant, tangent, and chord. Alright? So, in the next problem, we have a tangent line, which is 12. We have a radius, which is x, and we have a secant made up of x and 8. A secant is a line that goes through a circle. So, because this is a tangent line, or I'm telling you it is in the problem, you can justify that this is a 90-degree angle. Right? Now we have to math through to find r, the radius of the circle. What is the process that we're going to use? Pythagorean Theorem. A squared plus b squared equals c squared. Okay? So we're using tangents, secants, and radiuses just to do Pythagorean Theorem.
X squared plus 140 equals x squared plus 16x plus 16.
Double it. Square it. Alright, mental math. Say farewell to Felicia.
Cancel out x squared on both sides.
Farewell, Felicia. X squareds go away.
Subtract 64 from both sides.
Subtract 64 from both sides. Huh? Yeah. 5. X equals 5. So what is the radius now? 5. And then goes back to that lazy teacher right triangle. That's a 5, 12, 13 common Pythagorean triple. Yeah, Vex. 100%. Non-fiction. How do you feel about that?
Pretty good.
Okay,
Just gonna need practice.
so you need practice with Pythagorean Theorem.
No, I need practice doing it. Like, without having someone guide me.
Yeah, I mean, so I'm just trying to get you guys to realize that all of this is based on the fact that you know that that's 90 degrees. Once you know that's 90 degrees, you go back to the skills you already have doing a squared plus b squared equals c squared. Okay, so I'm going to skip this one to get to this question. Again, right? So we get to part. What? Put a line down the middle.
No.
Nailed it.
See, you didn't listen to me.
No, you didn't say it right.
From the point to 117 degrees.
The center of the circle.
The center of the circle to the question mark.
Why would you do that?
Because it makes 2 triangles.
Why would you do that?
So we can go to triangles.
Why would you make a triangle? Why are you making more work for yourself?
Because
So here's the problem. You guys see stuff and you're not entirely sure what to do. Okay, what are the 2 properties of tangent lines? 90-degree angle. So when a radius meets a tangent, it forms a 90-degree angle. When a radius meets a tangent, it forms a 90-degree angle.
Oh, so the 90. So then
180 plus 117 and minus 5, whatever.
What? How are you doing that? But you're right. You're all right. How many sides does that shape have?
4.
Which means how many degrees are inside that shape? So 360 degrees inside of this unknown quadrilateral.
90 plus
If I add all these angle measurements together, you get 297. If you subtract and find the number of degrees left over for that unknown quadrilateral, you get 63 degrees. Only if we could name that quadrilateral. It is a kite. And then Baker says, Why is it a kite? Shame on you. Who wants to be the brave soul?
It has two congruent adjacent sides.
Two consecutive congruent sides. Now, how can you justify that two consecutive sides are congruent?
Because of
Because the common point of the two tangent lines.
Oh, so because two tangents meet at a common point, we know factually that this piece and this piece are equal to each other. That is a property of tangent lines. Well, I gotta figure out how I can make the other two sides congruent. They're both radiuses, and all radiuses are always congruent, so these two pieces are congruent. Guys, it's only gonna get more fun as the year goes on. You might have a kite prism. That is a prism with a kite as a base, and you have to find the area of the kite and then find the volume of that kite. It's going to be great. Okay. What property of tangent lines am I assessing on you now? I'm asking, the question is, what is the perimeter of the polygon that is inscribing the circle? Okay, so how long is this piece?
Oh,
So how long is this piece? 17
Millimeters.
platypuses? Oh, millimeters. Okay. How long is this one?
7 millimeters.
Still 7. They are equivalent. Common endpoint, point of tangency, or equidistance. So if this is 8, how big is this one?
8.
Millimeters. If this is 3, how long is this one?
3.
So then you add up the distance around the shape, and it gives you the perimeter of the shape. You adding,
harder in algebra.
okay, this is tough, 15. This one's even harder, 24. This one's pretty rough, 20. Ooh, 11. And you have to add all those together. I like to add 20s together, that's a 44. And then 11 plus 15 is 26. And then I can do that in 70 millimeters. That's the perimeter.
Oh, in algebra you gotta find the middle one.
Oh, so you want to do,
No.
No, I don't.
you know, you don't want to do the area of the
No.
shape minus
No.
the area of the circle?
No.
Okay. Move on. Last one. Find the find the perimeter of the triangle.
Oh, 24 minus 15, right?
Oh, okay. So realize that this whole length is 24. This length is 15.
Oh, you have to do 24 minus 15.
So how? Well, this one's how long?
That's 15.
So that means that there's 9 left over because 9 and 15 make 24.
Yeah.
So this is 9. So that one has to be 12. So because that one's 12,
That one's 12.
this one's 12. So this whole side is 27, and then 27, 24, and 21 make 72 walruses. 72 feet. Cool. All right, and then
72.
this is the last one that I have. I don't know why people make this question so complicated. Here we go. That was nice, right? Oh, bad baker. Me. I'm going to change mine first.
So it's a 90.
How many degrees are in a triangle? 180. So 50 plus 40 plus 90 make 180.
Yeah.
It's confusing, right? The first time you see it. Is there anything else that I have forgotten to bestow upon you? No?
I don't know.
I'm just trying to think if there was one more that. Oh, here it is. Is the red line a tangent line?
Yes.
Bet your life on it.
No.
You're dead. If how would the red line be a tangent line?
Met the radius of 90
If what?
Met the radius of 90 degrees.
If that's 90 degrees. That would only be 90 degrees if a squared plus b squared equals c squared. Does a squared plus b squared equal c squared?
No.
So this is not a tangent line. Doesn't work. So there's a portion on your homework assignment that says, is it a tangent? Does it make a right triangle? So you're trying a squared plus b squared equals c squared to see if it works. I don't know how much time we have, but I have homework. You have 3 graded assignments this week. Please pay attention because I am deleting a bunch of questions. I don't want you to do too much work. 2:10, I think.
No, like,
That's what you got.
We have 1 minute.
Oh God, better hurry.